In this video, we are going to learn how to divide fractions. Before we dive into dividing fractions, let's think about what we already know about integers. So if we divide the following, 10 divided by 2, you should already know at this point that 10 divided by 2 is 5. Essentially, we are dividing 10 into two pieces that contain 5 pieces in each. But we can also multiply 10 by a number to get the same result. So if we think about 10 over 1, and we think about our final result, us wanting it to be essentially 5 over 1, we would essentially need to end up with the fraction of 10 over 2, because that simplifies to 5 over 1, or 5. Well, if we're going to multiply 10 over 1 times something, and we want to get it to be 10 over 2, which is in essence 5, we need to multiply it by 1 in the numerator, because 10 times 1 is 10, and 2 in our denominator, because 1 times 2 is 2. So essentially, dividing by 2 and multiplying by 1/2 are the exact same thing. And that's kind of the essence of dividing fractions, and I'll explain how that all ties together. But notice that 2 over 1, if we're dividing by 2 over 1, and if we're multiplying by 1 over 2, we get the exact same answer. So I want to take some time here to compare 2 over 1 to 1 over 2, because hopefully what you're seeing is that this is just a flipped fraction version of itself. If I just flip 2 over 1 over, I get 1/2. And these two numbers are what are called reciprocals of each other. So if we're dividing by a number, we can actually rewrite it as multiplication by multiplying by the reciprocal. And what I mean by this is if I'm doing 10 divided by 2 over 1, I can rewrite any problem from division into multiplication by instead leaving the first number, so doing 10, so the keep, switching the division symbol to multiplication, and multiplying by the reciprocal of 2 over 1, which is it's flipped over to be 1 over 2. So just like when we rewrite subtraction into addition and we use keep, change, we can write any division problem into multiplication by using keep, switch, which means we switch from division to multiplication, flip, where we flip to the reciprocal. And then once we've changed it to multiplication, the multiplication rules apply. So say, for example, we had 5/4 divided by 2/3. Looks like a super yucky problem. But if we use keep, switch, flip, if we rewrite division into multiplication, it automatically gets so much easier. So keep, switch, flip means keep the first number. So we'd keep 5/4. We then switch the division sign to multiplication, so there's our switch, and the flip is we take the reciprocal of the second number. So we take 2/3 and we flip it over to be 3/2. So by using keep, switch, flip, we've rewritten from division into multiplication, and now we know our rules of multiplication so well. We know we multiply our numerators, so 5 times 3 is 15. We multiply our denominators, 4 times 2 is 8, and then from there we simplify if we can, and if we can't, that's just our answer. So where we used keep, change to rewrite subtraction to addition, we use keep, switch, flip to rewrite division into multiplication. So here we're going to use our knowledge of keep, switch, flip to rewrite each division problem into multiplication, and then from there we'll be able to solve it by using our rules of multiplication. So here we're going to apply keep, switch, flip to rewrite this first problem. We keep the first fraction, which is 2/7. We switch division to multiplication, and then we take the reciprocal of the second fraction, so we flip it, and it becomes 7/9. And then from here, we multiply our fractions, so we multiply the two numerators together, we get 14. We multiply the denominators, we get 63. And then from here, I know that this is divisible by 7, as is this one. 14 divided by 7 is 2. 63 divided by 7 is 9. And that's fully simplified in my final answer. All right, this next one tends to be a little tricky because of the way that it's written. So I'm just going to rewrite this problem to start and say it's 3/5, this is a division symbol, divided by -5/2. So rewriting it just with the division sign can be a little bit easier. Then from here, we're going to use keep, switch, flip. So I keep the first one. I then switch the sign to be multiplication, and I flip it so it becomes 2/5. Now from here, I'm going to use my rules of multiplication. So I notice I have a positive number times a negative number, so my result is negative. My numerators are 3 times 2, which is 6. My denominators are 5 times 5, which is 25. Those don't have any common factors, so my final answer is -6/25. And then finally, if I look down at this bottom one, again applying keep, switch, flip because it is division. I have -4/9. I switch to multiplication and I flip that second fraction to be -8/6. So keep, switch, flip. Then from here it's a negative times a negative, so I know my final answer is going to be a positive. The numerators multiply together to be 32. The denominators multiply together to be 54. I then know that both of these are at least divisible by 2, so I can simplify it further. The numerator becomes 16. The denominator becomes 27. Those no longer have any common factors, so I am completely done simplifying. So now we're going to look at how we divide when we have integers and fractions mixed together. So just like we did with multiplication, we're going to turn all of these integers into fractions. So I can make this 8/1 and -5/1. So then from here, once I have two fractions being divided together, then I can just use keep, switch, flip to help me divide. So here in part A, I keep 3/4, I switch the sign to be multiplication, and I flip the 8/1 to be its reciprocal, which is 1/8. And then from here, I multiply my numerators, multiply my denominators. They have no common factors, so that's fully simplified. Then in part B, this one I'm actually going to rewrite as -5/1 divided by 7/10 to start, because for me that's just easier to look at. Then I can see it's the division of two fractions, so I use keep, switch, flip. So here I have keep the first fraction, switch to multiplication, flip the second fraction to its reciprocal. Then from here, I'm noticing a negative times a positive, so my result will be negative. My numerator is 5 times 10, which is 50, and my denominator is 1 times 7, which is 7. And then if I look there, they have no common factors, so that is my fully simplified answer. And then lastly, taking a look at mixed numbers. Our first step still, if we're going to do any operations on these, or we're going to turn them into improper fractions. So here I start off with 2 whole pies times 5 pieces, which is 10 plus 1, which is 11/5, divided by, I know that I have a negative here because it's a negative number, and then it's 3 times 2, which is 6, plus 1, which is 7/2. So I start off with 11/5 divided by a -7/2. Then from here I can utilize keep, switch, flip. So I'm going to keep the first fraction, switch it to a multiplication symbol, and flip it to be -2/7. So I use keep, switch, flip to change it from division into multiplication. And then from here, I can use my multiplication rules. So I am multiplying a positive times a negative, so my result will be negative. The numerator, 11 times 2, becomes 22. The denominator is 5 times 7, which is 35. 22 and 35 don't have any common factors together, so that would be our final answer.